Hello everyone, welcome to today's lesson on multi-step equations. So last time we talked about one-step equations, right? We just applied our inverse operation once. But this time, there's multiple steps, of course, like the name suggests. But luckily it's not very complicated. So last time we talked about how whenever we want to isolate the variable, we want to do the inverse operation, right? But now, when we inverse the operations, we also have to make sure that we inverse the order of bed mass as well. Okay, so remember with bed mass, and we got brackets first, exponents, division, multiplication, addition, and subtraction. Hey, so we do the inverse order. So instead of going from the brackets down to the subtraction, right, we go subtraction and addition, and then multiplication, division, and then exponents and brackets. Right? But to be honest, the most important part, right, the most important part is this one here. Right, well, actually, more specifically, we always do addition and subtraction before multiplication and division when we're working backwards. So here's an example here. All right, first step, as usual, we isolate the variable, which is a in this case. However, right, we got a on both sides, right? So we have to somehow scooch them around so that the variable is on this side and all the numbers is on the other side. Right, so it doesn't matter which way you want to move it. We can move this a to the left side or 2a to this side, and reverse order works fine as well. Personally, I like to keep things positive. Right? I don't like to work with negative numbers because I might make mistakes. So, first step I like to do, right, is to move the variables onto one side. So, again, applying the inverse operations here. Right, so noticing how I'm doing the subtraction and addition first. Right, notice how we have a 2a here, but we could just divide everything by 2 and stuff. But again, we want to do subtraction and addition first. Right, so let's subtract a from both sides. Now we just have a on the left-hand side and no a on the right. Right, and then again from there, inverse operations once again, make a more isolated. We add 3 to both sides. So a is 8. Okay, that's it. So now let's put multiplication and stuff into the mix and division. Alright, so once again, we scooch the variables first. Okay, it doesn't really matter which order you do it. You can move the numbers first as well. Okay, we want to move the 2b onto the left side. So we got 3b on the left, and everything else on the right. We add 4 to both sides to move this guy over there. 3b, oops. -1 plus 4 is 3. And of course, last step, we just divide everything by 3. Right, so again, notice how I'm doing all this adding and moving around first. So adding, subtracting first, and then I'm doing the multiplication / division last. Right, so that's what we mean by reverse order of bed mass. Whenever we solve for x, we do the reverse order. Because we are essentially just working backwards to find out what the variable is. So that's why we have to reverse the order of bed mass as well. Because when we do it, we do the, like I said, front or the normal order of bed mass. Anyways, 3 divided by 3 is just 1. Oh, keep using the wrong color. Alright. Yeah, that's pretty much it for just a multi-step. That's the whole process. So now before we get into some word problems, right, here's some common phrases that you might encounter. Right, and of course, half of math is like the actual calculating part, but the other half, which I think is the more important part, is actually understanding where to use it. Right, like we can learn all about multiplication all we want, but if we don't understand where to use it, what's the point, right? So, of course, we have to understand it from words. Right, here's some common words that you see in word problems. So, it might be something like the sum of a number, right? The sum just means the result of adding something. So the sum of a number and 5. So in this case, the quote-unquote number here, right? A number, a number we're talking about. This is the variable, right? The quote-unquote a number is the something that we want to know. Right? A number, a number, a number. Right? This quote-unquote a number is a mysterious thing we want to figure out. So that's our variable. That's our x, our unknown. The sum of a number and 5. So that's same thing as x plus 5. Right? So the x plus 5 is the sum. 9 more than a number. So we have a number here. 9 more than that is just that number plus 9. A number increased by 11. Right. So we start with an x, a number, we go up by 11. Right. So now wording is really important here. 4 less than a number. We have a number, there's 4 less of that, so we do minus 4. 8 minus a number. We have 8 minus a number. Right, so be very careful with the wording here. We have 8 minus a number, so 8 minus x. And then we have 4 less than a number. Right, so in this case, x goes in front because it's 4 less than something. A number decreased by 2. Right, minus 2. 7 times a number, straightforward. 7 times x. Right, again, we don't need to write the signs, or we don't have to write the multiplication sign here because it is ignored when we have a number and a variable together. Once again, we do not write multiplication because we get something like this. Super confusing. Believe the mathematicians who decide to, make multiplication of x, right? Twice a number. Twice a number is just 2 times something. 12% of a number. So here's a fun one, right? We talked about percents a while back. All right, so remember, percent just means over 100. So 12% is just 12 over 100. And remember, what is decimal over that? To convert onto decimal, right, we start with 12. 12 divided by 100. All right, 12 divided by 100. Right, so we can move our decimals, right? Our decimal default position is behind the numbers. If we divide by 100, we move our decimal 2 places to the left, to here. Okay, so we get 0.12. 12% of a number is just 0.12 times whatever the number it is. Right, so if you ever see something like, oh, this is like 50% off, it's 0.5 times the number. Quotient. Right, so quotient is a result of a number being divided. So quotient of 5 and a number is just 5 divided by x. Right, or as a fraction, just 5 over x. Half a number, just divide that by half, the number by half. The quotient of a number and 4. Right, so notice how the wording is very important. Quotient of 5 and a number is 5 divided by the number, the x. So if it's a quotient of a number and 4, you can imagine it's the opposite, right? X divided by 4. There are common English terms that you will see in math to denote the what operation we use. So we can put them to use here for big word problems. Here's the first one. The sum of 3 times a number and 3 is negative 23. Find this number. Okay, so we can actually find some important information here, or highlight some important information. So we're looking for the sum. That's the most important part. And then we can see that it is 3 times number and 3. So the sum of 2 of those things is negative 23. Right, so there's our piece of the information here. The sum, so it's plus sign for sure. 3 times the number and 3. So we got 2 numbers. And one of them is 3. Right. So the sum of those 2 things is negative 23. Negative 23. Okay. And now what's here? Right. It's just 3 times a number. Again, a number just means x, right? And our goal is to find this number. And that's why we know it's x, because our goal is to find this number, which is our unknown, which is our variable. And we know that 3 times this number, so 3x plus 3 is negative 23. So now, right, we just solve it. We do our inverse functions first, right? So, careful here, right? We have 3x here, but again, we isolate that last, right? We do the multiplication and stuff last. We do addition and subtraction first. Okay, let me just scooch all my things up here. So 3x equals to negative 26. Divide everything by 3. So x is just negative 26 over 3. Right? Because 26 is not divisible by 3. We can put it as a reminder or a remainder. Right? So another acceptable answer I can take. Right? Could be, what is this? 8 remainder 2. Right? You can do 8 remainder 2 as well. Okay. Next one. So Link here charges $3. Right, so that's our first hint. So he charges $3. I should actually highlight the whole thing here. He charges $3 and then 0.60 cents for $60 for every bokoblin he needs to get rid of. Right. So this is for every bokoblin he needs to get rid of. So for every single one. And now the question is asking, how many bokoblins did he have to get rid of for this total amount? For $19.20. So as usual, let's figure out what the question wants us to ask. Like, what's our variable? What's our x? Right, so now, the question is giving us how many bokoblins does he need to get rid of for this money? Which means that the unknown, our goal for this question, is to figure out how many bokoblins. Right, so which means that the bokoblins here is our variable, that's our x. Right, so here's our equation. Right, so the amount of money he earns, right, is $19.20. That's the total money he earns. And we also know that he charges, right? He charges $3 first, and then $0.60 for every single bokoblin he needs to get rid of. So once again, bokoblin is our x here. That's the thing we want you to know. So if he earns $0.60 for every single bokoblin he needs to get rid of, the same thing as just, okay, so for every single x, he earns 0.6 on top of that. Right? So again, he charges $3 first, right? So it's always going to be there. So we already have a 3 here. And then he also earns $0.60 for every single x he gets. Oh, little covering there. And we know the total amount is 19.2. So our equation here is 19.20 equals to 3 plus 0.6x. Okay, and business as usual. And look here, right? Our variable now is on the right-hand side. Right, we can just leave it there. As long as it's by itself, doesn't really matter which side it is. Inverse operation first, subtract 3 from both sides to get 16.2 equals to 0.6x. Divide both sides by 0.6. X is 27. Okay, so 27 bokoblins he needs to get rid of. Okay, just like that. Okay, let's do the harder ones. A husband is 2 years younger than his wife. First hint. So 2 years younger than his wife. And his son is half the age of his mother. Right? So we know right away that the husband's wife and their son's mother is the same person. Right? It's like your mom is the same thing as your dad's wife. Right? So this is one person. And if the sum of all their ages is 97, how old is their son? Okay, so right away, what's our x, right? How old is the son? So the son's age is x. And now we can do a quick little diagram here. So we got the husband right here. So husband is 2 years older than his wife. So the husband age is +2 of his wife. And the son is half the age of his mother. Right? Just like that. So this is our little flowchart there, if you will. Right? Because again, we know this because again, the husband's wife and the son's mother, same person. Right? The husband is 2 years older, so his age is +2 of the wife, and the son's age is half of his mother. So the son's age is just the mother's age divided by 2. All that added up is 97. Okay, so we know the son is x, and we know we're looking for the sum of the 3 ages. I should highlight the sum part as well. And we're looking for the sum. So we know their ages added up is 97. Okay, so if the son's age is half the age of his mother, that means the age of the mother is 2 times the son's, right? 2x. And we know husband has 2 more years on top of his wife, so it's just 2x plus 2. Okay, so that's how we set it up. And there we have it. So that's our equation. Combine on like terms. We got the x's that can combine, and then the number constant by itself. 2x plus 2x plus x is 5. Okay, now we do our isolation, do our subtraction and addition first. Divide everything by 5. So x is 19. So the son is 19 years old. Okay, again, we can double check this. So the son's age is 19. The mom's age is twice the son's. So 2 times 19, 38. Dad's age is just 2 years more than the mom, which is 40. Right? And if we add it up, we do indeed see that it is 97. So you can always double check those problems like this. I mean, technically, you could just start with if the son is 1 year old, then the mother is 2 years old, the husband is 4 years old, right? You can check every single number, but you know, especially when there's decimals involved, you'll be here forever. Okay, last one. So, first we have the sum, right? That's the important word. So we're adding something here. Sum of 13 and 3 consecutive even integers is 43. Okay? So this one's a lot more complicated. It's only one sentence, but it is a lot more work. So if we look here, the sum, right? So we know we're adding something of 13 and 3 consecutive integers. So 13 and 3 more numbers. So we're adding 4 things together. So 13 plus number 1, number 2, number 3 equals to 43. Right, so what does consecutive mean? Right, consecutive means one after the other. So consecutive numbers of, say, 4 is 5, 6, 7. Right, so those are the numbers after another. Consecutive, let's say 4 consecutive numbers after 17, we got 18, 19, 20, 21. Okay, that's what that means. So now we have even numbers. Now, how do we represent even numbers as variables? Okay, so here's what we can do. We want to find all 3 integers. Right, so that's our x. Right, but we cannot just say, oh, 13 plus x is 43, right? Because cannot be 3 numbers. X can only be one number at a time. So what we can have is, okay, how about the first integer? So the first integer, let's say that's x. Right? So the first integer is x. So the first of the 3 consecutive numbers is x. Right, so what's the one number after x? Right, the one number after x. Oh, I have like no space here. Just realized. Hope I got space here to solve the problem. So the consecutive number after x is just x plus 1. Right, because let's say, what's the number after 13? What's the number that's consecutive 13? We add 1 to 13, that's 14. What's consecutive after 14? We add 1, that's 15. But in this case, it has to be an even number, an even integer. So how do you find something that's consecutive that's even? Right? Because even numbers, right, think about even numbers. Even numbers is what, 2, 4, 6, 8. They're going up by 2 each time, which means that something that's consecutive and even, right, must be 2 more than the previous one. Which means that the consecutive even integer after x must be x plus 2. Because, again, if it's even, we're going up by 2 each time. That's the definition of an even number. So the integer after that will be x plus 4. I should think of, let's say, the even number of like 20. Right, what's an even number after 20? 22. What's an even number after 22? 24. Right, so we're going up by 2 each time. So the consecutive even number of x is just x plus 2, x plus 4, x plus 6, and so on. Right, again, this is a harder one. Definitely in the extending territory here. And as you can see here, right, now solving the equation is not the hard part. Oh, sorry. It could still be difficult, but not as difficult as finding the equation in the first place, right? Because now, again, we combine the variables, all the like terms. 3x, 13 plus 2 plus 4 is 19, equals to 43. Inverse operations, do the adding, subtracting first. By 3. So x is 8. So the first integer is 8. So what's this next consecutive even integer? We go by 2, that's 10. Next one is 12. Right, so notice here, solving the equation oftentimes is not as difficult as finding the equation in the first place. Right, you can double check this. Alright, let's see. 13 plus 8 plus 10 plus 12. Alright, let's see here. 3 plus 8 is 11. 11 plus 2 is 13. So we got 3 here. Carry over to 1. Alright, 43. Okay, that's it for today's lesson. Alright, so again, we always do inverse operations. So we always do now, when we're trying to solve for x, because we're going backwards trying to figure out what x is, we do our operations and our better maths backwards as well. Right, so always addition, subtraction first, before multiplication, division. Right, and after that, word problems. Right, the most important part of word problem is setting the equation up. Once you set it up, it's just solving for x from there. Alright, that's all. Good luck practicing.